The check engine light came on, so I started troubleshooting to identify the issue. I connected a scan tool and retrieved the diagnostic code P0717, input Turbine Speed Sensor A circuit, no signal. To gather more information, I performed a road test while monitoring live data on the scan tool. During the test, I noticed the transmission input shaft speed sensor readings would intermittently drop out, indicating a potential problem with the sensor or its circuit. Next, I inspected the wiring harness and connector for the transmission input shaft speed sensor. I looked for any signs of damage, loose connections, or corrosion, but everything appeared to be in good condition. With the ignition on and the engine off, I used a multimeter to check the sensor connector for voltage and ground. Both were present, confirming that the circuit was receiving power and ground as expected. To further diagnose the issue, I back-probed the sensor and monitored its signal on a lab scope while performing another road test. The lab scope displayed an erratic signal from the sensor, confirming that the transmission input shaft speed sensor itself was faulty. Based on these results, I replaced the transmission input shaft speed sensor with a new one. After the replacement, I cleared the fault codes and performed a road test to ensure the repair was successful. The vehicle operated smoothly, and the transmission input shaft speed readings were stable. The check engine light stayed off, and no fault codes returned. This process highlights the importance of thorough diagnostics. The input shaft speed sensor plays a critical role in the operation of the transmission, providing real-time data to ensure smooth gear shifts and proper performance. A faulty sensor can cause issues such as erratic shifting, reduced fuel efficiency, and potential transmission damage. By systematically testing the circuit and the sensor, I ensured the problem was accurately identified and resolved, restoring the vehicle to optimal condition.